Okay, so what happens if we are asked to find the slope of the tangent line to the given function at the x-coordinate that's given? All right. Probably what you want to do is you want to find the general derivative first, like find the derivative of the function with x, and then plug that x value in to get your actual value. That's going to be the easiest. So I have assigned for you A. That one's really easy. I don't want to spoil it for you. Let's do D. 3D. Okay? So g of x here is the fifth root of x. And we're going to examine this at x equals 32. So I actually want to know what is the slope of the tangent line to this function when x is 32. You don't have to know what this function looks like. You don't really have to know. All you have to do is find the derivative g of x, and then we're going to put g prime of x, we're going to put g prime of 32, and we're going to evaluate that. And that's going to be your slope. All right? All right, so before we actually get to g prime here, let's rewrite this in a way that's a little bit more friendly. If we have the fifth root, that's like writing x to the power of 1/5. Very good. So if you're wondering what to do with this root sign, if you just write it as a fractional exponent, it becomes really easy. Now we just do the power rule. So we can find the derivative now. And the power rule says that we want to bring this 1/5 down to the front as a coefficient. So that's going to be 1/5 times x. X to the what? Well, we are going to subtract 1 from 1/5. So if we have 1/5 and we subtract 5/5, what do I have left over? Negative 4/5. Awesome. And that's it. That's all we do. Now, of course, we could rewrite this if you want. And we could rewrite this like this. This could be, this brings
please call 205.
the negative exponent here brings this term down to the denominator. So this would be like 1/5 times the fifth root of x to the power of 4. And of course this 4 really could be written outside of the root sign, no problem. And that's actually going to make this a little bit easier. Okay? All right, so everyone's cool with this jump from here down to here? Because that's what this is. In the denominator, that's what this becomes. Okay? So, oh yeah, let's go actually all the way up to here then. Let's put in 32. Now what does that look like? Well, let's show some steps here. So we've got 1/5 times the fifth root of 32. Huh, that's no problem. Right? Fifth root of 32, what's that? It's 2. Right. Said with a yawn there. All right, somebody's tired. All right, no problem. 1/5 times 2 to the 4. Okay, what's 2 to the power of 4? 16. What's 5 times 16? 1/80. So that should be your slope. Now, whether they give it to you in a decimal, probably not a decimal. Good idea to keep your answers in fraction form, especially if it's like a irrational something, root something. Don't put a decimal. Just leave it in exact form when possible. Okay, so that should be the answer to 3D, finding that slope. Any questions? All right, so here's the next step here, the next level. And this level is find the equation of the tangent line to the curve at the given point. So the equation of the tangent line requires two things. To make an equation, you need the slope. Good idea, have the slope. Oh, the slope of the tangent line, we can do that, right? Find the derivative. Plug in the x value, get the slope. And then to make an equation, we need the slope and a point. We're given a point. Awesome. All right. So, I don't know, A looks pretty easy. C looks kind of iffy. Let's do B. Why not? B looks kind of semi-hard. Let's give B a shot here. 2 root x. At the point 9, 6. Well, aren't they just wonderful to us? They give us both the x and the y value. They could have just given us the x value, in which case we would have had to plug the x value in there to find the partner y value, but they give that to us. So the equation of the tangent, let's find slope first. We need to find that. Well, that actually is y prime evaluated at x equals 9, right? Or f prime of 9. That's what it is. So if f of x is 2 root x, f prime, well, let's simplify this a little bit. Let's rewrite this, because remember, radicals, what do we do with a radical? Well, you have to transform that in your head to get it to a power. So why don't we just write it first as a power? That's x to the power of 1/2. Everyone see that? So f prime of x is, power rule, says the 1/2 comes down here and multiplies by whatever is already here. So what's 1/2 times 2? That's just a 1. So it's going to be 1x to the power of negative 1/2. Very good. All right. So you don't have to simplify that at all. Don't worry about it. Let's take this now, right here, and let's put in 9 in for x. So f prime of 9 is actually 9 to the power of negative 1/2, which is 1 over square root of 9, which is 1/3. So we have our slope of our tangent line is 1/3. Is everybody down with that? Any questions on that, or are you okay? You're okay. Okay. Good. So now we need to find the equation of the tangent line. So of course, we're going to use y minus y1 equals m times x minus x1, because that is the point slope form of a straight line, of a linear function. And we've got the slope right here, and we've got the x value right there, and we've got the y value right there. So this is easy. Easy breezy. Plug it in. Y minus 6 equals 1/3 times x minus 9. Remember, this x and this y stay as x and y so that we can have this linear function describing how x and y are related. What we could do is you could leave it like this, actually. This is totally fine. That's a point slope form of a line. But the textbook, I know, doesn't leave it like this usually. They either put it in general or standard form, or y equals mx plus b is really nice if we have to graph it, right? So you might want to put it in a different form. So let's see. Let's do y equals, take that 6 over, and let's simplify this. 1/3 x minus 9 over 3 is 3, and that 6 becomes a plus 6 over there. So we have 1/3 x plus 3. So that's y equals mx plus plus b. That's great. And we could also put it in, I guess, general form, which would be where the x and the y and the constant, if there's one, would all be on the one side and it equals 0. And the x term has to have a whole number coefficient, positive integer. So let's see. Okay, so this is going to be 1/3 x. If we keep that positive, let's bring that over, minus y, and that stays over there, plus 3 equals 0. And then we multiply everything by 3 to get this coefficient to be a whole number, so that's by 3. So it's going to be x minus 3y plus 9 equals 0. So those 3 would be acceptable. First one's pretty easy, but I don't think you'll see that as a quoted answer in the back of your textbook very often. Okay, so did I do anything wrong here? All this mental math in my head here, we good? Looking at you guys, being distracted. Everyone's okay with that? Awesome. All right.